بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Major 1, Math 111, Term 232. Let us have a look to the major and solve it together. The first question, there is a graph given, and there are some questions about it. Use the graph of f to find the following values. Find the limit. What is the limit of f of x when x approaches 1 from the right? So x approaches 1. Where is x here? This is x, and this is y. So x is approaching 1. So this is 1. X is approaching 1 plus. Plus means from the right. So when x approaches 1, for example, it becomes 2, 1.9, 1.8, 1.3. Where is the function? Where is the graph? Well, if x is 2, this is f of 2, which is 4. If f is 1.5, we are here almost, okay, at 2. So as x approaches 1 from the right, the graph is going down and approaching 1. So the limit is 1. When x approaches infinity, okay, now we have to take x to infinity, not to 1. So where is infinity? This direction. So we have to take x to this direction and look to the graph. Where is the graph? This is the graph here. And it goes where? It goes like this, where it approaches the line, this line. What is the equation of this line? The equation is y equals 6. So it approaches 6. So the limit is 6. What is the limit of f of x when x approaches negative infinity? Okay, now x approaches negative infinity. So this is x. To the right, we go to the infinity. To the left, we go to negative infinity. So x goes to negative infinity means we are going in this direction. Where is the graph going? The graph is going here, where approaching the x-axis, which is, what is y here on the x-axis? On the x-axis, y is 0, 0, 1, 2. So on the x-axis, y is 0. So the limit of f of x when x approaches negative infinity is 0. So this is how we find the limit, either from the right, from the left, any number, we can find it using by this method. List all the horizontal asymptotes. What are the horizontal asymptotes? The horizontal asymptotes are horizontal lines like this line, in which the function approaches this line when x goes to infinity or when x goes to negative infinity. So actually, these two limits give you the equations of the horizontal asymptotes. To find the horizontal asymptotes, you find the limit when x approaches infinity. And we found that it's 6. So this line, which has the equation y equals to 6, is a horizontal asymptote. When x approaches negative infinity, the function approaches 0. So this line, what is the equation of this line, the x-axis? Y equals to 0. So the two horizontal asymptotes are y equals to 6 and y equals to 0. List all the points where the function is not continuous. By the way, do we have a vertical asymptote here? No, there are no vertical asymptotes. Vertical asymptotes are vertical lines like this, in which the graph becomes closer to them when x approaches a number, okay? So we find the limit when x approaches negative 1 number, not infinity. And the limit should be infinity or negative infinity. Okay, points where the function is not continuous. Well, the function is not continuous where? He said list all the points, okay? He means the values of x at which the function is not continuous. So when x equals 1, the function is not continuous because there is a gap here, okay? The limit from the right is not equal to the limit from the left. The limit when x approaches 1 from the right is 1, but if we approach 1 from the left, the limit is 3. The limit does not exist at 1, okay? So that's why the function is not continuous at 1. So you can say the limit. There is no need to write this, but I'm telling you the reason. The limit of f of x when x approaches 1 does not exist because the limit from the right is not equal to the limit from the left. The function is continuous at 2, okay, but there is no derivative here because there is a corner, and also at 3. So it's not differentiable at 2 and 3, but he asks only about continuity. So that's the answer. Find the inverse of this function. Well, to find the inverse, first we write f of x as y. So y is equal to 4 plus the 11th root of x raised to the power 7. Now, the first step could be either solving this equation for x and then interchanging x and y, or interchange x and y and then solve the equation for y. Okay, both are correct. So, well, I'll start by solving this equation for x. To solve this equation for x, I have to get rid of the 7. So I take the 7th root of both sides. So I'll have the 7th root of y equals the 7th root of power 7. They cancel each other, and we have 4 plus 11th root of x. To solve it for x, I need to get rid of this 4. So take it to the other side. So I'll have 11th root of x equals negative 4 if you take it to the other side, plus the 7th root of y. Now finally, to find x, I have to get rid of the 11th root. What to do? I raise both sides to the power 11. So when I raise the 11th root of x to the power 11, they cancel each other and I get x. And on the other side, I'll have negative 4 plus the 7th root of y raised to the power 11. Now we solved the equation for x, so we just interchange now y and x. And this is in fact f inverse, but finally we replace y by f inverse and say that f inverse of x is negative 4 plus 7th root of y to the power 11. If you want to check that your answer is correct here, you didn't do any mistake, you can, for example, replace x by any number here in f of x. If you replace x by 0, what would happen? You will see that f of 0 is 4 to the power 7. So in fact, 0 goes to 4 to the power 7. F takes 0 to 4 to the power 7. F inverse, if your definition is correct, F inverse should take 4 to the power 7 to 0. So if you replace, of course, if you write F inverse x, and here also I did not replace, this should be x, because I interchanged x and y, and also in the final step here, this should be x. So if I replace x by 4 to the power 7, I'll have 7th root of 4 to the power 7. They cancel each other and I get 4. 4 minus 4 is 0. 0 to the power 11 is 0. So in fact, my answer is correct. Use a table to estimate this limit. Well, x approaches 2 from the left. So if this is the number 2, and we are approaching from the left, so what is the number to the left of 2? I have 1 on the number line. This goes to infinity, this goes to negative infinity, the 0 is here. So if x approaches 2 from the left, you should replace x by values to the left of 2 and find the corresponding values of y, where y is this function, 1 over pi tan inverse 5 over x minus 2. So 1, I can start from 1, but 1 is very far from 2. So if I take a number very close to 2, you can say 1.9. So 1.9. Let me replace x by 1.9 and find the answer. You go to the calculator, okay? You enter this function, okay? 1 over pi. You can write pi as it is, shift pi, okay? Then times tan inverse. You have to make sure that you are in the radian mode, okay? Shift mode and choose the radian mode. Any inverse functions, always in this course, you need radian mode. So please be always, make sure that your calculator is always on the radian mode. Tan inverse, then you write tan inverse and fraction and then 5 over and replace x by 1.9. 1.9 minus 2, and let me see the answer. The answer is, okay, let me write the answer. It is negative 0.4936. It continues, but I'll take only 4 digits. That's enough for me. Okay, he said table, so I should choose more than one value. So I come closer, more closer to 2. So I'll choose 1.99, for example. So the same function, I go reverse to the left, and I add 9, so 1.99, and I ask the calculator for the answer, and the answer is negative 0.49936. Let me come more closer. So I'll choose 1.999, okay? And I add 9 in the calculator going to the left. And the answer is negative 0.49936. Do you see a pattern? Okay. Is this number becoming closer to a known number to you? What is negative 0.49999? It's in fact negative 0.5. So finally, from this table, I understand that the limit of 1 over pi tan inverse of 5 over x minus 2 when x approaches 2 from the left is negative 0.5. Notice that if you replace x by 2 here, you always, when we find the limit, we should replace x by the number here. So 2 minus 2, 0. 5 over 0 is not defined. Okay, 5 over 0 is positive or negative infinity. So we can't use this limit. We can't find this limit by direct substitution. So we have to use a table like this. And we can use a table, in fact, to get to the answer. So the answer is negative 0.5. Use transformations to graph this function. First, what is the original function? Well, the original function is y equals ln x. What is the graph of y equals ln x? This line is a vertical asymptote, and it passes by this point, 0 and 1. Sorry, 1 and 0. X is 1 and y is 0. This is the function ln x. Now this 2 means what? Means 2 units to the right. Shift this graph 2 units to the right. 2 units to the right to graph what? To graph ln x minus 2. So when you shift the graph 2 units to the right, this line, which is vertical asymptote, will be here at x equals 2 instead of x equals 0. And the x-intercept 1, 0 would be here at 3, 0, and the graph would be like this. So this would be the point 3, 0 in this case. And finally, plus 2 means taking the graph up 2 units. So 2 units up to sketch the graph of the function y equals ln x minus 2 plus 2. So what to do? The asymptote, the vertical asymptote is not going to change. But if you take this point 3, 0 up 2 units, you will reach this point, which is 3 and 2. And then the graph would be like this. Okay, so this point would be the point 3 and 2 when you take this graph 2 units up. So this would be a rough graph or a nice graph of this function. We used transformation to sketch the graph. Evaluate the following limits. Well, when x approaches infinity or negative infinity, there is an easy method to find the limit. We just take the highest power in the numerator, which is negative, the term with the highest power, over the term with the highest power in the denominator. We notice, now we simplify, we notice that x to the power 5 cancels with x to the power 5, and then we will have negative 1 over 3, and that's the limit. Now, when x approaches 1, we first start by replacing x by 1. If we replace x by 1, we will have 9 minus 9, that's 0, and 1 plus 3 is 4 minus 4, that's 0. When we have 0 over 0, this means that the limit exists. There is a limit, but we need to either factor or multiply by the conjugate. Well, we don't have a root here to multiply by the conjugate, so we can factor, in fact, the numerator. Either you factor or you expand x plus 2 square. So let us expand x plus 2 square. We get x square plus 2x times 2, that's 4x plus 4. This is how you expand x plus y to the power 2. It's x squared plus 2xy plus y squared minus 9 over, let me try to factor the denominator. Well, I have x minus 1 and x plus 4, because this will give you negative 4 minus 1 plus 4. You can use the calculator here to factor. How? You go to mode 5.3 and you choose equations 3, which is ax squared plus bx plus c. What is a? The coefficient of x squared. B, the coefficient of xc is negative 4. So you put 1, 3, negative 4. The calculator will give you 1 and negative 4. The calculator says 1 and negative 4, so you write it x minus 1 and x plus 4. So this would be the factored form of the denominator. Notice that 4 minus 9 is negative 5. So let me also factor the numerator. You can use the calculator if you like, but for me it's easy because I search for two numbers, their product is negative 5 and their sum is 4, and I know that x approaches 1, so x minus 1 should be one of them because we got 0 over 0, so these two has to cancel together. So I'll have here x what plus 5. So minus 5 minus 1 plus 5 plus 4. If you use the calculator, you will get 1 and negative 5. So you write it like this. Now we cancel x minus 1 with x minus 1. And now we can replace x by 1 to find the limit. Keep the limit always. Keep the limit there until you replace x by this number. When I replace x by 1, I get 1 plus 5, which is 6, and 1 plus 4, which is 5. So the answer is 6 over 5. All right. I can check my answer, whether my answer is acceptable or not. How? By replacing x by a number very close to 1, like 1.0001, for example. So I write, I open a bracket, I write 1.001 plus 2, and then close the bracket squared minus 9 over 1.001 squared plus 3 times 1.001 minus 4. What is the answer? Calculator says 1.1999. Well, 1.199 is 1.2, and 6 over 5 is 1.2. So my answer is correct. It's good to check always that your answer is correct. You can always check the limit using the calculator. Let g of x, this is a piecewise function, find the value of c so that the function is continuous at 9. Remember, the function will be continuous at 9 if the limit when x approaches 9 of the function is equal to f of 9. Well, what is f of 9 here? If x is less than or equal to 9, so to find f of 9, I replace x by 9. So f of 9 is in fact square root of 9 plus c. And the limit has to exist. So the limit from the right should be equal to the limit from the left. So we start by finding the limit from the right or from the left of f of g of x here. Okay, this is g of x. So let me just write it g of x because the name of the function is g. Okay, okay, this is also g. What would be the definition of g of x when x approaches 9 from the right? When I approach 9 from the right, I use numbers greater than 9. So greater than 9 means the definition is x squared minus 81 over x minus 9. And now I need to find this limit. To find this limit, I replace x by 9. 9 squared is 81. 81 minus 81, that's in fact 0 over 0. So what to do when we have 0 over 0 we just mentioned? We try to factor or multiply by the conjugate. There is no conjugate, so factor x squared minus 81. This is x minus 9 times x plus 9. To factor u squared or a squared minus b squared, that's always a minus b times a plus b. So 81 is 9 squared. So x minus 9 times x plus 9 over x plus 9. This cancels with this. And now I can replace x by 9. 9 minus 9 is 0. So the limit from the right is 0. Okay, what is the limit from the left? Well, if I approach 9 from the left, I'll use this definition, which is in fact equal to g of 9. So it is 9 plus c, sorry, this is c. X plus c, 9 plus c. So for the function to be continuous, f, or not f again, we used to use f, g is continuous at 9, f square root of 9 plus c equals to 0 if the limit from the right equals to the limit from the left. So to solve this equation, I raise both sides to the power 2, and then the value of c would be negative 9. So that's the answer. He says, find the value of c so that the function is continuous at 9. So if I replace c by negative 9 here, I'll have x minus 9. And when I replace 9, x by 9, I'll get 0. So I'll get 0 from the right, 0 from the left. This will make the function continuous at 9. Find the horizontal and vertical asymptotes. We mentioned to find the horizontal asymptotes, we find the limit of the function when x approaches infinity and negative infinity. Let us start by finding the limit when x approaches infinity. Well, if I replace x by infinity, you should know the graph of e of x. This is the graph of e of x. So this is y equals ex. So from this graph, e to the power infinity means when x approaches infinity, the graph goes up. So e to the power infinity is infinity. While when x approaches negative infinity, the graph approaches 0, so e to the power negative infinity is 0. This is important. So x to the power infinity, e to the power infinity is infinity. 4 times infinity, infinity minus 5 infinity, so 3 over infinity, and that's in fact 0. So y equals to 0 is a horizontal asymptote. Also, we need to find the limit when x approaches negative infinity. Well, negative infinity, e to the power negative infinity is 0, so this would be 0, and I'll have 3 over 0 minus 5 or negative 5. So also y equals to negative 3 over 5 is another horizontal asymptote. So this function has two horizontal asymptotes. To find the vertical asymptote, I look to the denominator, and the value that makes the denominator 0 will give me the equation of the vertical asymptote. So to solve this equation for x, I take 5 to the other side. And to get rid of ex, I have to divide by 4, because if you apply len, then I have 4 here. And I know that len ex is x, but you have to apply len to ex, not for ex. So now you can apply len and to both sides. And len cancels e, and the equation of the vertical asymptote would be x equals len 5 over 4. That's the end of the exam. I hope that you enjoyed solving it together. Have a nice time and see you in another video.